Today's lesson is graphs of simple polar equations. My learning objective today is I can graph the 6 basic polar equations without the use of a calculator and verify with a calculator. So this is a investigation. We're actually going to use our calculator to see what the equations look like so that we don't need to use our calculator when we're looking at these equations. So we're going to use the calculator, list what the criteria, and then come to some conclusions. So we're going to fill in the first page as we're working through the investigation. All right, so we'll start with here on number 7 where it says r equals 3. So to review, we have angles going around in circles. I start my 0 degrees. Let's see here. Let's say my 0 degrees is here. And if we're looking 1, 2, 3 makes up 90. So these are 30 degrees apiece. So I'm just counting by 30s, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and back to 360. So if it says the radius is 3, we said starting at the pole, each ring out is a radius of 1. So it doesn't tell me what the angle is, so it actually means all angles. So at 0 degrees, my radius is 3. So 1, 2, 3, I would have a point here. At 30 degrees, my radius is 3. At 60 degrees, my radius is 3. So every angle, my radius is 3. So it's all the angles that are shown plus all the angles in between. Okay, so when I have a circle with the center on the pole, I have r equals a number. All right, so let's look at number 8, which is the other extreme. This time it's giving me an angle. So the angle is pi over 4. So again, this is 0 radius. So this is specifically talking about at pi over 4. So I know pi over 4 is 45 degrees. So pi over 4 would be this angle here. So whereas number 7 says I'm specifically 1 radius at all angles, this one is saying I'm all radii at 1 angle. So at 45 degrees, I'm the radius of 3. 45 degrees, I'm the radius of 1, radius of 2, radius of 3, and all the angles. So I actually fill in this line. So when I see a radius is a number, this includes all angles. When I have an angle is a specific angle, I have all radii. So I can go fill in number 1 and number 4 on the front. So number 1 says a circle with a center at the pole. So we had a center at the pole, the center of my circle, and the radius was A. I would see from here to here is my radius, A. And number 4, we did, so this was R equals A, whatever the number is. And a line type where we have a line through the pole. I have an equation where the angle equals A. So the angle equals theta equals A here. All right, let's keep on with our investigation. So I want to confirm these using a calculator. So you want to go to your calculator and see what does a radius of 3 and a radius of -3 look like. So to do this, we're going to go into mode, and this time we're going to be in polar mode. We want to make sure that we have, we're going to type in our equation. So our equation R is 3 and -3, so I'll do one at a time here. We're going to use these settings for the window. And then you need to make sure you change the zoom to Z square, and now it'll look like a circle. Okay, so we're going to do this and confirm it on our calculator. All right, let's move on to the next one. This time I want to solve for my radius. So I want to solve for R. So I'm going to divide by what is next to it. So I'm going to divide by the sine of theta. So R equals 2 divided by the sine of theta. And I'm going to fill this in my y equals. So I am going to start, and I'm going to be doing it at these different angles. So I'm going to look at what's going on at these different angles. So I'm going to go back around, and my angles are in radians. So I want to list the radians around my circle here. So here is 0. These are 30 degrees. 30 degrees is pi over 6. So here is pi over 6. Pi over 3 is 60 degrees. Pi over 2 is 90. This is 2 pi over 3. 5 pi over 6. Pi. 7 pi over 6. 4 pi over 3. 3 pi over 2. 5 pi over 3. 11 pi over 6. And 2 pi. So to put these in our calculator, we're going to divide these out, or to put them in our calculator. So I'm going to take 2 and take the sine of 0. So 2, the sine of 0, I'm going to see my radius is undefined. I'm going to type in R is 2 divided by pi over 6, the sine of pi over 6. And I get my radius is 4. So substituting the angle in here, I'm calculating each individual radius. So I get 2.3, and I'm going to round to tenths. So 2.3, 2, 2.3, 4, undefined, minus 4, minus 2.3, minus 2, minus 2.3, minus 4, undefined. Okay, now I'm going to go graph these. So I'm going to start out at 0, and my radius is undefined, so I can't put a point there. So at pi over 6, my radius is 4. So 1, 2, 3, 4. At pi over 3, my radius is 2.3. So 1, 2, and a third. At pi over 2, my radius is 2. At 2 pi over 3, my radius is 2.3. So we should kind of be getting an idea what kind of line we're talking about here. 5 pi over 6, my radius is 4. 1, 2, 3, 4. At pi, it's undefined, so it's not there. At 7 pi over 6, I have a negative radius. So that means it's 180 degrees the other direction. So it's repeating this point again here. At 4 pi over 3, it's a negative radius, so it's 180 degrees. So it's the same point at pi over 3. At 3 pi over 2, the radius is negative 2, so it's the same point at pi over 2. At 5 pi over 3, the radius is negative 2.3, so it is the same point here at 2 pi over 3. At 11 pi over 6, the radius is negative 4, so it is the same point at 5 pi over 6. And then at 2 pi, it's undefined again. So what I see is I have a horizontal line. Okay, so here's my horizontal line. Okay, so use our calculator to confirm. So let's graph if I type this in, and do I see r equals 2 divided by the sine of theta? Do I see a horizontal line like what I'm seeing? I want to confirm that. So this is if I was looking in the rectangular system, this would be a horizontal line, and this would be a y equals 2 line. So let's graph r equals, or r sine of theta equals negative 3 on my calculator. So solving for r, I would get r equals negative 3 divided by the sine of theta. So the rectangular, what would the rectangular form of this be? What I see is the rectangular form is y equals this portion here. So this would be y equals negative 3. So I should see a horizontal line at negative 3. So at this point, I should be able to fill in number 5 in our table. So let's go back on the front and fill in number 5. So when I have a horizontal line type, I'll have an equation that says r times the sine of theta equals a. Putting it in my calculator, I was solving for r equals a sine of theta. But putting it in my calculator, I see this. So my a is whatever I am above or below the 0, or the polar axis, where we're calling this the polar axis. All right, let's keep going on our investigation. Okay, so we finished this. Okay, now I have r cosine of theta equals 1. Let's use our calculator to sketch this. So again, I'm going to solve for r. So I would say this is r equals x divided by the cosine of theta. So the rectangular form of this is x equals 1. As I am using this equation here. So specifically for this would be 1 divided by the cosine of theta. So let's graph. What does r cosine of -4 on my calculator look like? So solving for r, this would be -4 divided by the cosine of theta. So I would graph this. So I'm sorry, we're graphing this first one here. So this is at 1. So x equals 1 is a vertical line. And my radius is 1. So if I graph this, this is what I'm going to see. If I graph this next equation, I should have a vertical line at x equals -4. So now I should be able to fill in, what does number 6 in the table look like? Okay, in the table. So then I have a vertical line type. And I know my equation is, from here to here is a. And I was solving for r equals, it's going to be a divided by the cosine of theta. Okay, I have a little bit more to go. Okay, I'm going to do the same thing. Again, I'm going to mark my angles here. So this is 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. Okay, so I'm going to do the same thing. So here r equals 4 times the sine of theta. So at each angle, I'm going to say 4 times that. So 4 times the sine of 0 degrees is undefined. 4 times the sine of pi over 6. I'm sorry. 4 times the sine of 0 is 0. 4 times the sine of pi over 6 is 2. 4 times the sine of pi over 3. Again, I'm going to round 1 decimal place, 3.5. 4 times the sine of pi over 2 is 4. 3.5. 2. 0. -2. -3.5. -4. -3.5. -2. And 0. Okay, so I'm going to go back and I'm going to plot these points now. So at 0 degrees, my radius is 0. At pi over 6, my radius is 2. At pi over 3, my radius is 3.5. 3.5. At pi over 2, my radius is 4. 2 pi over 3, my radius is 3.5. 5 pi over 6, my radius is 2. And at pi, my radius is 0. At 7 pi over 6, the radius is -2, so it's 180 degrees. So I am repeating my point at pi over 6. At 4 pi over 3, my radius is -3.5, so I'm repeating the point at pi over 3. 3 pi over 2, I'm at -4, which is 180 degrees away, which is pi over 2. So I'm repeating this point. 5 pi over 3, I'm repeating the point at 2 pi over 3. 11 pi over 6, I'm repeating the point at 5 pi over 6. And at 2 pi, I'm repeating this point at 0. So here is my circle. Okay, so we are going to use my calculator, put this in and confirm. Next, I want to graph individually, one at a time, r equals 2 sine of r equals negative sine of theta, and r equals -3 times the sine of theta. So what can I make? What conclusion can I make about the graph r equals a times the sine of theta? I should be able to fill in number 3 on the front now. Oh, number 3 on the front is a circle with the center. The center of my circle is here, which is on the y-axis. And my diameter is A. So A is from here to here. All right, we are almost through. For number 12, r equals 4 cosine of theta. Let's sketch this one. And we put this in the calculator. I see I have 1, 2, 3, 4. Looks like this. So I have a circle. And I'm interested in where is the center of the circle. So the center is on the x-axis. And then this is my A value right here. All right, so we're going to go fill in number 2. So when I have a circle, the center on the x-axis, the diameter is A. So here's the center of my circle. That's what I'm interested in. And A is here to here. Okay, that's it.